Our next topic is recursion. This is very important topic because a lot of functions or the procedures can be written using recursion. That is, they can be written as recursive functions. So let us learn about them. So what are the topics that I am going to cover in this video? What is recursion? Example I will take and explain by tracing of that recursion, how to trace it, how to know the output of a recursion. Then a recursion uses stack. So what does it mean? How it uses a stack, that I am going to explain you. Then also I'll show you how to find the time complexity of any recursive function. So let us start with what is recursion. Now before showing you recursion, first of all let me remind you one thing. Here I have one example program, that is main function and one more function called function fun. And this main function is calling this function. So how this function call is made, how it works, let me remind you this. Already I have explained you in my previous video. Let us look at it again. See, once I start executing my program, it will start executing from main function. First it will execute the first statement, then second statement, then the third statement is function call. It goes to this function, enters inside, execute first statement, second and third statement. Once it has finished, the function ends and the control come back to the same line, that is third line. If any more operations present in this line, they will execute. Otherwise, it will execute fourth line and fifth line. What does it mean by any other operations? For example, this function is returning something, and here I have written multiplied by 2 something. So the value of that function has to be multiplied by 2. So this multiplication will be done once the function has returned here with some value. Assume that that function has returned 10. So 10 into 2 can be done only if this function has returned the result. So once again quickly, program starts, first line, second line, third line, control goes here, first, second, third, function ends, control returns, anything pending that will be done, and then remaining statements. This is the important point that you should remember for understanding recursions. So let me explain you next about recursion. Let us look at a general form of recursion. So here I have an example. This is a recursive function. So what does it mean by recursive function? A function is calling itself. So if a function is calling itself, then it is called as a recursive function. So a function, inside that if you see, it is calling itself again. So this is a recursive function. Then one important thing inside recursion is, here you can see that this is a base condition. Condition is there. So there must be some base condition that will terminate recursion. There must be some method to terminate this one. Otherwise it will go into infinite calling. It is just like this. First we call the function first time, then it will call itself, again call itself, again it call itself. So repeatedly it will be calling again and again. So there must be some condition at which it must stop. So in this example, this will call itself if the condition is true, or it can stop if the condition is true. Whatever it is, at some point it must stop. So here if the condition becomes false, it will not call further and it stops. So finally, let us look at it again. A function calling itself is called as recursion, and inside recursive function there must be some condition which will make the recursion stop, terminate. So in my example, if the condition becomes false, it will stop. That's it. So let us take some example of recursive function and study how it works. Let us look at an example. Let me explain you the example. I have a main function which is having some value and calling function fun1 by passing that x, and function fun1 taking parameter n, and if the condition is true, it is printing and then calling itself. I have used a C language code here. So it's printing and again calling itself for a reduced value of n. If whatever n is, suppose n is a 5, then it will call itself for 4. So if I am passing 3 from here, what will be the result? How it works? Let us trace this recursive function and check. Now tracing. How to trace a recursive function? Recursive functions are traced in the form of a tree. So let me start tracing this one. See, inside the function there are two steps that it has to perform if this condition is true. First step it has to print, second step it has to call itself by passing n minus 1, and this it has to do only if n is greater than 0. Let us start. From here I am calling function fun1 by passing x, that is value 3. So here fun1 by passing 3. So first time it has got 3. 3 is greater than 0. Yes. First step, print n. So first step is print 3. Then what is the second step? Call itself again fun1 for 3 minus 1, that is 2. So it will call itself again by passing fun of 2. See, inside the function there were two steps. Both the steps I have completed. First step was printing and the second step is call. So printing is nothing but the output. So what is the output I got so far? Output is 3. Then what about this? It's a call again. Whether this call has finished? No, it has completed first line, second line. It has not yet came out of the function. It has not yet came out of the function. It has to come out. But it is calling this one. So let us execute this. Fun of 2. Again start. 2. 2 is greater than 0. Yes, 2 steps. So the first step is print 2. So the output 2. Then call itself for n minus 1. So fun of 1. Now still this call has not finished. It has printed and it has to call this one. So again a new call, fresh call. Again a fresh call. So that fresh call is fun1 with 1. So fun1 with 1. 1 is greater than 0. Yes. So perform two things. First step, print 1. So in output we get 1. Then the second thing is call for 1 minus 1. So fun1 of 1 minus 1 is 0. Now fun0, fun1 of 0, n, that is 0, greater than 0? No, it is not greater than 0. It will not enter inside, so it will not perform these two steps and it does nothing. So no printing and no calling, and it will not enter inside and it will come out of the function. So this call doesn't do anything. So there is no further calling. Then what it has to do? It will go back to the previous function and come out of the function. So this function finishes. It go back to the previous function that is in this line and come out. Afterwards there is nothing remaining, so it will simply come out and go back to this function and comes out of this one. Then it will come back to main and terminates. So from this call it goes back to the previous call and then previous call, just like the way just now I have shown you how a function terminates and it goes back to the place from where it was called. So this is a tree and this is called as tracing tree of recursive function, and this is the output. Now I will take one more example and show you. So this example I'll just move it aside, then I'll use this portion for showing you next example. Now I have one more example of a recursive function. This is more similar to the first one. Let me compare them and show you. If you check the main function having variable x and calling function fun1, here also main having variable x and calling function fun2. Inside fun1, it is taking parameter n and n greater than 0, two things are done. Here also taking parameter n greater than 0, two things are done. But the difference is, here it is printing and then calling itself. But here, first it is calling itself, then printing. Then what will be the output? So let us trace this one. So this is a minor difference between these two functions. Let us trace. So from here I start. First main function is calling this function fun2. So by passing value 3. So first time function fun2 will be, this is 3. 3, n is 3, so 3 is greater than 0. Yes. So first statement is what? Call itself for n minus 1. Second statement is print. So first statement, it will call itself for fun2 of 2. N is 3, so 3 minus 1, 2. Then what about the next statement, printing? It will not be done. First, this call has to finish, then only it will print. So let us take this call. Let us finish this one. So it will call itself again with n equal to 2. 2 is greater than 0. Again, two steps. So first step is call with n minus 1. So n is 2. So it will call itself for fun2 of 1. And second statement, it will be done after this first statement has finished. What is the first statement? Fun2 1. 1 is greater than 0. So call itself for n minus 1. So again next call, fun2 of 1 minus 1 is 0. And printing, that will be done afterwards. First this has to finish. Now fun of 0, that is fun2 of 0. 0. 0 is greater than 0. No. So it will not enter inside this if block. And it will come out. So it does nothing. So this call with parameter 0 has terminated. Now once this call has terminated, the control should go back to the previous call. So previous call was this one. It was called from here. So it will go back to this function call in this line. This line was this one. So this has finished. Now the next line is print n. So what is n value? 1. So it will print 1. So the output is, first output is 1. Then it will go back to this previous call. And second thing that is remaining here, that is printing. Printing it has to do. So the value 2 is printed. Then this will come out of this and finish. So this call finishes. It goes back to the previous call. In that call, it has completed this fun of 2. You can see that this complete fun of 2 is in deep. It is completed. Then the second statement, print n. So the value of n is 3. So this is 3. So this is the output of this function. So you can see that the function values are 1, 2, 3. And here the output was 3, 2, 1. Now let us compare them. In this function, first the printing was done and the recursive call was made. Print and then call. Print and then call. Print and then call. But here, first call is made, then printing is done. So first call, then call, then call, then call. So again now return back. Print, return, print, return, print. So here printing was done at calling time. Before the function is called, printing was done. But here printing is done at returning time, when the function is returning to the previous call. So at the returning time, printing is done. And the difference here is printing is done after the function call. So that portion will be done at returning time. So I have shown you the differences between them. Now let me take one example and show you the differences among them. See, suppose there is a room and there is a bulb in a room and there is a door. And from that room, you can enter into one more room. This is the door for it. And there is a bulb fixed in this one. And one more door, there is a bulb fixed in this one. This is room 1 and room 2 and room 3. 3 rooms and each room is having a bulb. Now, if I give you the instruction saying that switch on bulb, second step is go to next room. So these are the 2 steps if I ask you to perform recursively. So there are rooms like this, right? So nested room, room inside room. Now, if I make you stand here and ask you to perform this recursively, then what you will do? Let us check. You will switch on bulb, first step. Second step, you will go to next room. So the first bulb that you have switched on is 1. Let us call it as output. Then you will enter into next room. Then here what you will do? Again recursively, so switch on bulb. So you will switch on second bulb and then go to next room. You will enter this next room. Then in this room again first step is switch on bulb. So you will switch on third bulb and go to next room. There is no next room further. So it was more like a recursive call, a function calling itself again and function calling itself again. Now this is termination. There is no next room. What you will do now? you will definitely come out of those rooms. Your work has finished. So from third room, you will come back to second room. Now, will you do anything now? No, you will simply come out. You will come out in the first room, then you will come out of the first room also. So third to second, second to first, then you will come out. And you simply come out. Nothing you will do. So it means first stage was you were entering in. So it was just like a calling. And after you have finished this one, you cannot go further. So you will return back. So this is returning. So you have gone through two phases. One is calling phase, other one is returning phase. Or I can say that this was ascending and then descending. So you were going to next, ascending. Then you came back and back. So descending. So you have done ascending and descending. And at descending time, you have not done anything. Now, I'll give you one more example. First step is go to next room. And second step is switch on bulb. These are the two steps. I have changed the order, you can see. Go to next room, then switch on bulb. Now let us see if these are performed, then what will be the result. If you are here, then I have given you two instructions. Go to next room. Then second step is switch on bulb. So first what you will do, you will not switch on bulb. You will go to next room. Then there, again the first step is go to next room. So you will go to next room. There, again the first step is go to next room. So there is no next room. There are no rooms further. Then you will perform second step. Switch on bulb. So the first bulb to be switched on is third bulb. Then definitely you will come back to the previous room. And in this room you will switch on second bulb. And you will come back to the first room, switch on first bulb. That's it. So I have two different versions of steps here. In first set of steps, switch on bulb, go to next room. So the bulbs were switched on in this order, 1, 2, 3. So where is the recursive call? This is the recursive call. First perform the operation, then the recursive call. Here, first the recursive call, then perform the operation. So the main important thing that I have to show you here in recursion is that recursion has two phases. One is calling phase and the other one is returning phase. So bulbs were switched on while going, bulbs were switched on while returning. So if you see this recursion, print and then call, switch on then go to next room. So this is same as that one. And if you see this one, go to next room then switch on. So here in this example, first go to next room, that is make a call and then print. So this is similar to this one. So finally I can say that recursive functions are just like a rubber band. If you stretch a rubber band, pull it, so next. If you release, it will come back. So same way, recursive function call and then return. So there are two phases. So that's how these are compared. But one thing that may confuse you, just let us look at this one. See, the first value was 3, 2, 1. So the printing was 3, 2, 1. But here the room numbers are 1, 2, 3. Don't compare this with that one. Just understand the procedure, how it is working. Otherwise, I can change the room numbers 3, 2, 1 also. So the output will be similar to them. So the important thing that we have learned here is that recursion will have two phases. One is calling phase and one is returning phase. Now I'll write a general form of recursive function once again and show you.